Okay, so this is part 2 of our video from on estimating and what happens when we change components. So we're going to do some more examples. So page 45, we're actually looking at page 46. So we looked at what happened when we changed certain dimensions. Now we're going to do some more examples. Shanzay is a carpenter and is making pyramid-shaped trees out of plywood for a winter display in City Hall. All the pyramids have a square base with sides 4.9 meters long. The slant height of the pyramids vary from 5.5 meters to 18.2 meters. How much more plywood is needed for the largest tree than the smallest tree? So the base always stays the same. All we're doing is changing the triangular faces. So we have to think about that when we're doing our calculations. So we have two different slant heights, right? The small one is 5.5 and the large one is 18.2. So the base stays the same. But the triangle sides change. And that way he gets different trees of different heights and it looks really cool. So surface area for the small is equal to, well, we have the side squared for the base, right? Plus we have 4 triangles, which are base times height over 2. Okay, now again, the base stays the same. The base is 4.9 squared, plus we have these triangles, and it's going to be 4.9 times, well, the small one is 5.5 divided by 2. Okay, when you multiply and add that up, the surface area for the small adds up to 77.41 meters squared. Oh, sorry, no, that's 91. My mistake. 91. Reading my calculator wrong. Okay, and that's just squaring this and adding it to that. Okay, now the surface area for the big, and I'll change colors just so we can see it. Again, the base is side squared plus 4 times base times height over 2. But the triangles are going to be different sizes now. So this will be 4.9 squared plus 4. And we have 4.9 times 18.2 because they're a lot bigger. And when we multiply those through, we get 202.37 meters squared. So the difference in plywood between the largest to the smallest, we'll use yet another color difference in plywood. We're going to subtract, right? So it'll be 202.37 meters squared minus 77.91 meters squared, which equals, 124 meters squared. So that's how much more plywood he would need to build a large tree compared to a small tree. So quite a big difference. I mean, we just want to know the amount of plywood. Sometimes we ask for times, how many times, but this is how much more for plywood. Peter is an interior designer. He sees this spherical light fixture that costs $40. Peter wants to use the same light fixture in a client's home, but with a radius triple this one. How much can he expect to pay for the bigger fixture? Well, that's assuming that it's related to the surface area, right? We're assuming, right, depending on how much bigger. So let's find out the surface area of this sphere as the currently is 4 pi r squared. And we don't know how big it is, right? So let's assign a value to it, and then we'll triple it. Okay, because right now it doesn't tell us how big it is. So let's say that this is, no, let's use the radius because that's what we want, right? Let's assume that this is 3 inches. Okay, we're just going to give it that value just to get a number for it. So we would have 4 pi 3 squared, which will give us 113.097 inches squared. So that's for this one here, right? So if we triple it, then it would be 9 inches. So 4 pi r squared is equal to 4 pi 9. We put in a 9 because this is triple. So that's times 3. And when we do that, we get 1017.8762. Okay? Now we want to know how does this affect the surface area? Obviously, you're going to have a lot more there, right? So we're going to take our 1017 and we're going to divide it by 113.097. And when we do that, we get a 9 times. So what that tells us is that it takes 9 times more material. So $40 times 9 equals 360. So that's how much you would pay for something that was 3 times the size. Okay, and we put in a 3 there. What you'd find is if you put a 2 in there, so it would be 2 in the first one and then 6 in the second one, you would still get an increase of 9 times because it's that tripling factor that is affecting it. Okay, try it. Try it with different numbers. Try with different numbers with a different radius. Okay, and all you have to do is make sure that you've tripled it each time to see what happens. Now I want you to try this one. So this would be a good time to pause, and then we'll figure it out together. Okay, you're back. Kieran is a carpenter. He designed a prism-shaped treehouse for a client. The cost to build it will be $40 per meter squared of surface area. Now the client wants to know how much it would cost to increase the depth of the treehouse from 2 to 3 meters. So we're talking about this value here. So we want to increase that to 3 meters. That's the depth of the house. Okay, so let's start by figuring out the surface area as is. So surface area, we'll call it the OG surface area, right? Is the area of the base times the height. So that's base times height over 2 of the triangle times the current height, which is 2.0. I should write that as the current height just because. And then I'll fill in the numbers in the next thing. So this would be the base of the triangle is 3 times the height is 2.6 over 2 times the height of our prism, which is 2.0 meters. Okay, and my OG surface area is 25.8 meters squared. Now, in the next part, all we're doing is we're changing. Oh wait, I'm doing volume, not surface area. Please rewind. Please rewind. You're saying, miss, that's not what I got, that's not what I got. So let's erase that and start over. Because it's surface area, right? Oh my goodness. Surface area, OG. So we have 2 triangles, right? Because we have a triangle at the front and one at the back. And we have 3 rectangles. And they might be all different sizes. In fact, I think they are. It's an equilateral triangle, so actually, no, they're all the same size. So we have 2 triangles, base times height over 2, plus 3 rectangles, which are length times width. So let's substitute that in. 2 times, we have 3 times 2.6 over 2 plus 3 times, and it's our length is 3 and our width is 2. 3.0 times 2.0. So this, when we get our calculation here and we multiply that out, we get 25.8 meters squared. Now, surface area new, and let's actually do that in blue so we can tell the difference clearer. So surface area new, well, same formula. The only thing different is that we have a different measurement for our width. Okay, so we will have 2 times 3 times 2.6 over 2, that stays the same, plus 3 times 3 times 3. Okay, and when we add that, we get 34.8 meters squared. Okay, so what's the difference? The difference is 34.8 minus 25.8. The difference is 9 meters squared. And it costs $40 per meter, so 9 times 40 equals, oh, I can barely see this. 9 times 40, I'm going to have to, 9 times 40 equals 360 more. Okay, alrighty. I'm so sorry I started doing volume instead of surface area. My apologies. Okay. So the next is a bit of exploration. So trying different things to kind of figure out what happens with each things. And I said we would go through these. You should have tried these on your own. So what happens when the base is changed? So we're going to take a look at this. And we can do that with numbers, or we can think about it in terms of a formula. Now, it's always better to try it with numbers and see what happens. Okay, so the base is unchanged and the height is doubled. So, say we have this as 1 and 1, right? And for our height, we say the height is also 1. And I'm using 1s because they're the easiest, right? So we know for our volumes, it's area of the base times height divided by 3, right? So the area of the base will be length times width times height divided by 3. And if everything is 1, it'll be 1 times 1 times 1 over 3. So it'll be 1/3. Now, if we double the height, so the only thing that changes is we change that height to 2, we will get base times height over 3. So it'll be length times width times height divided by 3. We're going to get 1 times 1 times 2 over 3. So that will be 2/3. So the volume doubles. What happens when the base is unchanged and the height is tripled? So let's try that. So volume is equal to base times height over 3. Length times width times height over 3. Length is 1, width is 1, height is 3. So we get 3 over 3, which is basically triple of the original, and it increases. So the volume, if we triple the height, the volume triples. So really changing that height has an impact on what's going on. Now what happens if the height is unchanged and the area of the base is doubled? So volume is equal to base times height over 3. Now when we had 1 times 1, we had basically our area was 1. Now if we're going to double that, we want an area of 2. So 2 times our 1 for our height So I'm comparing it to this original one. Gives me 2/3. Okay, so what happens if you double the size of the base, the volume doubles. Okay, so we can see kind of the impact. Is it possible to double the volume of a cylinder by doubling its height? Explain using an example. Well, why not? If I have 2 cylinders, same size, and I stack them on top of each other, all I've done in essence is double the height, right? And that will double the volume. Now we can do that with numbers. So say my area of so let's give us a radius of 1 and a height of 1, radius of 1 and a height of 1. So just doing one of them. Volume is pi r squared h. So volume is pi times 1 squared times 1. So it would be 3.14. And we'll just say it's meters squared. Okay? Now, if we're going to double the height, just the height, right? So it'll be volume is equal to pi r squared times height, but we're doubling the height. So r is 1, and the height now is 2. When we multiply that out, I get 6.28 meters squared. So it doubles the volume. Okay? If you're not sure, test it out. Try some different numbers. That's what I do. Okay, sonotubes are used for concrete footings on outdoor structures. Lila needs to put footings that are 5 feet in diameter. She considers a tube with 6-inch diameter, they're 5 feet in length, and one with 12-inch diameter. Compare the volumes of concrete number needed in cubic feet. Okay, so she has one that has, so we're basically changing our diameter. So for the first one, she has a diameter of 6, so that means our radius is 3, and we have a height of 5 feet. Correct? Yes. For 2, we have a diameter of 12, which gives us a radius of 6, and again, our height is 5. So let's try both of these out. First one, surface area, it's volume. Volume equals pi r squared h. So pi r is 3 squared times 5, and we get as a value 0.98174. Okay, for our second example, don't really need that over there. I get volume equals pi r squared h. I put it in. Pi r is now 6 and h is 5. So I multiply that through and I get 3.92699. Now, I want to compare these two, so I'm going to compare by dividing. So, if I compare, I take my 3.92699, divide it by 0.9817444, and it's approximately 4 times. So, by doubling the diameter, I basically have 4 times more concrete just by doubling the diameter. Okay, so changing the diameter has a big impact on that. You know, some of these are just testing them out, trying different things. As you notice, I like to put in the number 1 because it makes things simpler. And then if you double a number 1, it becomes a 2. Okay, that's pretty straightforward. But that's what we're looking at today. Hopefully that was exciting for you.